Hi everyone, so in today's video we're going to look at multiplayer team games. Most games will actually have some element of teaming involved because that's what humans tend to enjoy when they're playing video games. Or any activity, they tend to be quite social creatures. So it might be quite fun to create a multiplayer team-based game. So over the course of this tutorial series I will sort of move around different ideas for what an example game might be, and we'll look at implementing those options based off a template file. And it might be that over the course of this tutorial series we build off several different template files. For now we're going to use the one from last week, which included a connection system. So whenever a player connects, we want to assign them to a team, and that team should have some distinct characteristics like colour or the spawn position. So what we're going to do in this video is demonstrate how you would do this. If you want to spawn your players in a different manner, watching through the course of this tutorial series will give you an idea of how you might go about doing that. So there's quite a lot going on here, but it's actually very simple in its working. So we're first going to look at how we spawn the player before we look at what the player actually does. So on the dispatcher, which is the object that's used by the networking layer to capture Blender messages, which is what the RPC system uses, we have some server and client-specific logic. I mentioned this before, but the way that this happens is that the dispatcher is network enabled, but we don't actually replicate it by giving it a remote role of none. So it does involve in the networking system, but it doesn't actually do any networking code because it is disabled with a remote role of none. Now on the client state in this dispatcher, there isn't a lot going on. You'll see that there's basically a start connection code, and that's basically it. There's also this final layer at the back, which is a listener, and that's to be run on all network and server, client and server, for the reasons I mentioned earlier about message interception. Now on the server net mode state, we have the rule system, which is being initialized, and that's required to ensure that players can connect. And there's also this event when the players do connect. That's called controller request, and it's executed when a controller requests to spawn a player. Now when this happens, it triggers three things. Number one, we actually send the spawn message, which is controller assign Suzanne, and anything after this trailing underscore at the back is considered the name of a network object to add into the scene. The expression controllers will actually check what the current team value is. Spawn team is a property in the game object properties, and it's a boolean, and we will toggle that property as every player connects to ensure that each successive connecting player is spawned to a different team. So, depending on which team you're selected, we either set the team red with a message, or set the team green with a message. And then, as I said, once we've run the controller request, we toggle the spawn team. So where do these messages go and who uses them? Well, if you look at the spawn positions, there's actually nothing running on them. They're actually completely functionless to the point where you could delete them and nothing would happen. But they're quite useful for working out visually where things are supposed to happen inside of the editor. The rest of the logic is actually on our layer 2, and it's on our spawned network object. So see that I have two objects here, red team Suzanne and green team Suzanne, and they serve as visual messages. I can't speak. They serve as visual message. They serve as visual message, and they serve as visual meshes, and they serve as visual meshes to replace the mesh of the current object, which is this white object in the center called Suzanne. So Suzanne will switch to one of these meshes depending on which team Suzanne belongs to. So the rest of the logic is split between several different places. Let's actually take a look at the server state, because that's the state that does most of the thinking. On the server for Suzanne, we receive two messages, set team red and set team green. Depending on which message we receive, we either run the go to red action and the set team red property by setting the property team, which is a string property, to red, or the go to green action and the set team green property actuator, which sets our team to the green string. So this is these two controllers and four actuators are responsible for setting the current team. Now there's also some RPC logic, and all that this does is send the position and orientation to the server, which I've mentioned in a previous video, and this runs all the necessary logic we need it to do. In this specific instance, these messages are actually not sending the position, but they're receiving the position and actually applying it using these Python controllers here. And you'll also notice at the very bottom right of this state in the actuators column, there is the disable init state. And what this does is it removes the current state, which is the third state, so that the only server state that's left running is state 2, which sends the position. What this effectively means is that this state here is a server-only init state, which is run once when the object is spawned, and as soon as it's assigned a team, this state stops running. So this is all the server logic. Let's look at the client logic. The client logic does basically everything you'd expect. It dumps the position and orientation to the properties, as I mentioned in a previous tutorial. It also runs the movement function with movement.keyboard, which is a very primitive means of moving the player around in the scene, and it's very good for demonstrating in a simple way how things are working. Ideally in your games you'd run some more complex movement code. Now there's also an AND controller, which is triggered by the same always true pass sensor. And the purpose of this AND controller is basically to trigger two messages, both of which send or invoke the RPC calls to send the position and orientation to the server. Now the only thing left is how we actually set the colour of the player, because we've already set the location in the server state, which I'll show you once more, in go to red, which plays an action. But I prefer to actually not use actions to set the colour of the player, just because it was good to demonstrate some new functionality as well. So the way that the player changes its colour is through a replace mesh, and it's run on this visible layer in the final state of the object. Now this state is selected as an initial state, and because it doesn't belong to any network states, the column down here, it's not selected in any of these two states, that means that it will run for both states. And that means that whenever the property team is changed, both the server and the client will change their message accordingly. So on the server, that's guaranteed to happen, because the server, if we look at that state, changes the property of team to red, and therefore on the server it's also running this state, and it will see that the team has changed, and it will set the colour using replace mesh accordingly. Now on the client this will also work, but it requires that the client can also get the change to the property team. And the only way that can happen is using an RPC call, which you can see I don't do because in my RPC calls panel there's only two RPC calls, both of which send the position and the orientation. So the only other option is to use a replicated attribute, and you'll notice that this team property has the speaker icon enabled, which means that it's being replicated. So long story short, whenever that attribute team on the server is being changed, the client object will receive that message and change the team mesh. So both the server and the client can visualize the team. You actually don't need to visualize the team on the server, provided that the clients can receive the state, but it can be quite useful for debugging your games. So that's basically the entire system. If we go to my server, we're going to make it full screen, and we're going to save it, and we're going to start the server. And we're going to open up two clients, which I've already done so, if I can find them. Don't exit, there's one. I think I accidentally closed the other ones. That was very organised of me. Yeah, so here's my server. And we're ready to check that it's actually running as a server, so let's do that. Yes, it's running as a server, so we can start that in full screen. We can switch to the other client that we're going to spawn. There's two clients hopefully now visible. We're going to quickly make sure they are enabled as clients by going to the world settings, and I know where my options are, and changing the mode to client. And hitting P, and you'll see that we spawn a connection. And we're also going to go to the other client, who hopefully also is enabled as a client, and hit P, and you'll see that we also spawned. Now you can already see that the players are appropriately moving around in the scene. They have their own colours. One thing we did notice is they actually didn't teleport. I'm just going to quickly investigate why that is. Oh yes, quite simply that happens because when the player spawns, it starts sending its position authoritatively. So this does create some of the conflicts in the system. The fact that players can send their position authoritatively does mean that actually they have the ability to cheat with their position. So to actually make sure that the players spawn in the correct locations, we would actually want to trigger both the replace mesh code and the teleport code from the client. So both the server and the client would probably run the replace mesh, only the client would run the teleport code. But anyway, you can now see that we can have multiple clients connect and have their appropriate teams, and because I've actually had more than one client connect, there's actually technically 3 players in the sim, even though one of them was already disconnected. So this connection is I'll add in a future game, and it'll probably be handled by a message to the object in question, as we already sort of do with the RPC calls having custom messages. So that's it for this week, and in the next tutorial we'll look at another aspect of game development. Thank you for watching, and I'll keep you posted.